Let's solve a calculus problem involving parametric differentiation. We need to find dy/dx given that x equals a times cosine cubed theta and y equals a times sine cubed theta. To solve this, let's visualize what's happening. We can think of this as a curve where both x and y are functions of theta. As theta changes, we trace out a path in the xy plane. To find dy/dx, we'll use the chain rule with respect to theta. First, let's find dx/theta by differentiating x with respect to theta. Next, we'll find dy/theta by differentiating y with respect to theta. Now, we can find dy/dx using the chain rule. Remember that dy/dx equals dy/theta divided by dx/theta. Let's substitute our expressions and simplify. Notice we can cancel the three a terms in numerator and denominator. After simplification, we get negative tangent theta. Let's visualize what this means geometrically. At any point on our curve, the derivative dy/dx represents the slope of the tangent line, which equals negative tangent theta. And that completes our solution. We found that dy/dx equals negative tangent theta through parametric differentiation.